right, another example here. We have a 4 kilogram mass. I'm going to draw it to the right. So this 4 kilogram mass is traveling to the right at 4 meters per second when it breaks into two 2 kilogram masses. Okay. So one of the masses, so after the collision, actually it's not a collision, after this breaks apart, this is considered an explosion of sorts because this was one 4 kilogram mass and now it's 2 masses. One of these 2 kilogram masses has a velocity of 3 meters per second at an angle of 60 degrees north of east. And we want to find the velocity of the second mass. So the second one's got to be going down to the right because we have to conserve the momentum. So since it was one 4 kilogram object to begin with, and now it somehow broke apart into 2 objects, momentum is going to be conserved. So if I call the, let me redo this, sorry. I'm going to call this mass of 2 kilograms that we know the velocity for, mass 1, and the one we're trying to find, mass 2. Well, since they were one object to begin with, I'm just going to combine their mass. So the total mass times that total velocity initially, that's momentum, that's the initial momentum of the system, has to equal the momentum of mass 1 plus the momentum of mass 2 finally, not initially. So the initial momentum of the system is becoming final momentum of the 2 individual objects. Now again, because we have both x horizontal and y vertical motion occurring, we need to look at conservation of momentum in just the x direction and in just the y direction. Okay, so plugging these values in, but specifically for the x direction first. The total mass is 4 kilograms, and it is moving in the x direction specifically, initially, right before it falls apart. So that's the left side of the equation. That has to equal mass 1, this top one that has a velocity of 3 meters per second at an angle of 60 degrees north of east. So the mass, the x component of this velocity is going to be 3 cosine 60. So that's the momentum of mass 1. Mass 2 is going to have momentum that depends upon its mass and its x velocity. I'm just going to call this Vx final, meaning this V final that we're looking for, meaning this x component. Now I could totally write that as a V final cosine theta, but if I leave it as Vx final, I'm going to find that value. So let's see, we have 16 is equal to 6 cosine 60 plus 2 Vx final. So we can find this x component of the velocity that mass 2 has. This is 6.5 meters per second. So this second mass is going to be traveling quite a bit faster than this top one that's traveling at 3. So we now know this side is 6.5 meters per second. We can find Vy final looking at conservation of momentum specifically in the y direction. In the y direction, this original mass has no velocity. So we're saying that there's no momentum in this system initially, which is fine. That means the final momentum mass 1 has, because of its upward motion, so the mass times this 3 sine 60, so this is m1 v1 y final, that upward momentum is going to be balanced out by the downward momentum. Now I'm just writing this as Vy final. When I solve, I'm going to get my negative answer. So Vy final is going to be negative 60. 2.598, which, by the way, is going to be the same as this, the 3 sine 60 for the top mass, because if there is no momentum in the y direction initially, then the final y momentum of mass 1 has to exactly counteract the y final of mass 2. And because they have the same masses, then they're going to have the same y components of velocity. If they didn't have the same mass, the momentum would still balance, but they would not have the same velocity. So it's the momentum specifically that's balancing out. All right, our final answer, this problem is asking us for the magnitude and direction of this velocity of the second mass. So I like to draw in my components that I know. So we have figured out these components of velocity, meaning the final velocity of mass 2 will be this hypotenuse. So V2 final, the magnitude will be the x component squared times the y component squared. Pythagorean theorem. Square root. I'm getting 6.9999999. So 7 meters per second is the magnitude, so the speed. The angle, I can say the tangent of this angle is 2.598 over 6.5. So inverse tangent is going to be 22 degrees. It is specifically south of east. So that is our magnitude and direction of this velocity of the second mass. You could also say negative 22, that would be fine, but it's more appropriate to write it in terms of the east and south, since that's the way the information was given in the problem initially.